Hello everyone, welcome to my channel. In this session we'll see another most important classification algorithm in machine learning known as random forest. First thing, we are going to learn a new concept called as ensemble learning. Ensemble learning is when we take multiple machine learning algorithms and put them together to create one bigger machine learning algorithm, so that the final machine learning algorithm is using or leveraging many different other machine learning algorithm. Okay, so in this session we are going to see a random forest method which combines lot of decision tree methods. Let's understand the step-by-step procedure on how it happens. As a basic step, we have to pick up some random points, say k, from the training set. Okay, and once we done that, we have to build the decision tree associated to those k data points. Means instead of building a decision tree based on every thing you have in your data set, you build a decision tree just based on some of the data points you have in your data set, right? And in step 3, we try to choose the number n trees of trees you learn to build, and repeating the step 1 and step 2. And finally in step 4, for a new data point, make each one of your n trees predict the category to which the data points belongs and assign the new data point to the category that wins the majority vote. Okay, step 1, we pick at random k data points from the training set. Step 2, we build the decision tree associated to these k data points. In step 3, we choose the number n tree of trees you learn to build, and we are going to repeat the same step 1 and step 2. And finally in the step 4, for every new data point, make each one of your entry trees predict the categories to which the data points belongs and assign the new data point to the category that wins the majority vote. Okay, so that's how a random forest works. So basically you start off one tree and keep on building multiple trees, and each one of those trees is been built on a randomly selected subset from your data. And even though each one of those trees might not be ideal, overall on an average thing they can perform very well, right? And there's a major advantage of this algorithm, such as the power of a number can help to get rid of certain errors, okay, certain errors and certain uncertainties which is there in your algorithm, and makes it more precise. Okay, so with this keynote we'll see how to implement and apply the random forest algorithm for the same data set what we had seen for logistic algorithm, logistic regression algorithm, for KNN, also for the decision tree. Okay, the same data set has been taken for this, but we are applying a random forest algorithm, and will estimate the accuracy based on the other models which have been implemented, right? So first of all, we have to import all the libraries. For this case study we required only 2 libraries, NumPy and Pandas. Okay, import it, and after that we have to import the data set. As I already mentioned, the data set what we have taken for this case study is social network ads, wherein we have 3 important variables here: age, estimated salary and purchase. So the main objective of this case study is to predict whether a person is going to purchase a car or not based on the age and his estimated salary. Okay, totally 400 instances of data has been recorded, and we are going to utilize this data set to train our model. So this is how we do the importing of the data set to our workspace. We use the Pandas library and we invoke a method called read_csv, and we import this data set to our workspace, right? And once we are done that, we can see in the variable explorer a data frame has been created successfully, and all the values of from the data set CSV file has been successfully imported to the data frame, along with the age, estimated salary and the purchase. Okay, now it's time to split the data based on the independent variables and dependent variable vector. It is very clear from the data set that the age and estimated salary is considered to be independent vectors, matrix of features, and the purchase column to be the dependent variable vector. Okay, and to do that we have to select first two columns from the data set and store it in a variable x, and the last column we are going to store it in variable y. To do that we have to call the data set and locate the index value for all the rows and all the columns without the last one. Okay, so this will be your x matrix of features or independent variables, and this will be your variable dependent variable vector, because we are taking all the rows but only the last column, right? Now finally we have to split the data set into training and testing, right? So to do that we have to import one class called train test split, which we are going to take it from the model selection library, and which is going to give you two pairs of training and testing, like xtrain, ytrain, xtest and ytest, and through which we are going to create an instance of that class by passing the parameters x and y, independent variable vector and dependent variable vector, and keeping the size of the testing data set to 25% of it, and the random state is equivalent to 0. So we'll by doing this we can easily split up the data. Okay, so of course 25% of 400 becomes 100, and you can see it here, xtrain, ytrain, xtest and ytest. I think the operation is still under process. So let us see. Yes, it has successfully uploaded. You can see the xtrain here. Xtrain, out of I think only 300 instances of data has been recorded, 0 to 299. So last 100 has been taken for testing. Okay, and you can test it here, ytest, xtest. All right, here only 100 data has been taken, right? And you can also change the test size from 0.25 to 0.2 or 0.15. It is dependent upon the data set and how much quality data you have. Okay, now it's by looking at the data set, it is very clear that the data are not in a right scale. Okay, because few numbers are in different categories, like 30s are there, we have 20s, some numbers are in tens, and some numbers are in 50s. Okay, and it is same in the case of estimated salary. Now to bring out all this value into the same scale, we are going to do the feature scaling mechanism, wherein we are going to consider the approach of standard scalar here. Okay, so all the values after we do done with the feature scaling will be ranging from -3 to +3. Okay, so we are going to import this class standard scalar from the library preprocessing, sklearn scikit-learn.preprocessing. Okay, and it's very important that once we import any class, we have to take the instance of that class. Fortunately there is no parameters to be passed here. So once we store it in a variable, we have to fit the model to the train data set. Okay, so sc.fit transform to the xtrain. So we have to fit and transform the data to the train, but we are going to transform but we are going to consider only transformation for the xtest data set. Okay, because these are the data which we are going to test it at the end. Okay, we are not supposed to fit and transform the data, right? Only we are going to do that process for the training data set, not for the testing. That's the reason we had not used sc.fit_transfer, but rather we had only transformed the data for the xtest. And once we are done with that, we are ready to build our model. So as we know that for this case study we have taken a random forest classifier, and it is not there in tree library, because in decision tree classification we have seen that decision tree is present in sklearn.tree, but since random forest classifier is based on ensemble learning, so it will be there in ensemble libraries, because we are going to consider lot of decision trees, among which we are going to consider the best. Okay, we are going to go for multiple iterations by building more and more trees and try to fine tune it so that the results will be better. Let us justify that at the end of the session. Okay, we have to import this library class, and of course we have to create an instance of that class by passing parameters here, and you can see here n estimators. Okay, n estimators, I had taken it as 40. Let me take it as 10 at the very beginning stage. After that I will show you how the results are getting vary if we increase the number of estimators here. So here n underscore estimators is the number of trees in the forest. Okay, how many number of trees you are going to consider to be there in the forest, and the default value is actually 100. Okay, but since our data set is very simple, okay, we have only 400 instances of data, we'll take only 10 trees. Okay, or else if you take more and more, what happens is the model will be overfitted. If the model is overfitted, you may not get better results at the end. That's the reason, based on the data set, based on the number of instances in the data set, we have to decide how many number of trees which will be effective. Okay, so for this case study I had taken n underscore estimators equal 10, and the criterion what we had selected is entropy. By default it will be Gini, but for this case study we had taken the criterion as entropy, and the random state is 0. And once the model is built, we have to fit that model to the trained data set, that is X train and Y train. And please execute this code, and you can see that it will take some time, because for the to take a round of 110, right, it is going to take a lot of iteration. After few seconds you can see the model is built successfully. Now we are going to predict a new result. Okay, now let us take any values. So let me take 27, okay, with the age 27 and with the 1,20,000. Let me just predict it. 27, because that same value is not there here. Okay, I'm just trying with the random value. 1,20,000. Okay, now let us try to predict this one result. Okay, it is very clear that for this prediction we are getting that the person is not going to purchase a car. Okay, with 1,20,000. But let me take some other data with the 45 and 50,000, with the age of 45 and 50,000. Okay, let me just try to estimate the output here. So yes, it is saying 1, because we can see that based on the data set, most of the data with the age of 40s and with that particular range of estimated salary, there is a highest chance that the people have purchased the car. So the model is giving the right answer for this. Now we can try to predict all the test results and make it to display in a single way. Okay, instead of, we can't draw the graph for this because it's not 2D. So for that, what we have done means we have tried to use concatenate all the results, club that, segregate and display it in a single way. Okay, so we have to concatenate all the results. So for as a parameter we have taken 3 parameters here. One is for the prediction, another is for testing, and finally is the way in which you would like to display it, that is horizontal. Horizontal is 1 and 0 is for vertical. Okay, but inside the list, if you would like to see it in a vertical way, you have to put it as 1. You can see that we had reshaped, taken the length of every prediction and put it in a vertical manner. Inside the method you can see 1, but outside the method parameter you can see another 1. This is the parameter. Okay, this is the parameter for reshape method. Please do understand, this is for horizontal display, this is for vertical display. Okay, and get the result for this. You can see the results are out here, and most of the answers are rightly predicted. Okay, you can see it here. A few estimations will be wrong. None of the model will be 100% accurate. Okay, but still most of the answers are right. Okay, so now it's time to evaluate our model based on few performance metrics. The 2 performance metrics we are going to consider in this session is confusion matrix and accuracy score. where confusion matrix will give us an idea how many wrong predictions and how many right prediction among the data set we have, and based on that it is also going to give us the accuracy. Okay, let us try to execute it. Before that, we should know that we had imported this confusion matrix and accuracy score from the metrics library, which is there in scikit-learn. Okay, later on you create an instance of that class and pass the y-test and y-pred. Okay, one is tested value, another is predicted value. So among which we will decide how many are right, how many are wrong. So for that we have to execute this, and we can see that 91 are right predictions. Okay, 63 plus 28, 91 right prediction, 5 plus 4, 9 are wrong predictions. Okay, and if we see the accuracy of this model, it will be, of course, it will be 91%. Now let us also try with the more and more number of trees whether our results are going to vary. Okay, let me make it to 10 to 20 and let me check it again. So I'm going to run this code again. Yes, I can see some variation in the results, 92%. Okay, you can try till more until you get a better results. Okay, keep trying. Let me put 30 now and see the results now. Okay, it is same result. Okay, let me try for one more 40, making it 40. Let me check whether it is giving better result or not. Excellent, very good. So it is giving a 94% for the number of trees as 40, and if I make 50, what happens, we'll see. No, it is going down. That means I think for our case study, for our data set, okay, 40 can be the feasible number of trees you can take it in a forest. Okay, don't take it too much. Even we can take 100. If you think that 100 will give you better, it's not right, because if you put 100, then the model may overfit. Okay, so let me try with that also and see. The result is 91%. It is not mandatory that based on number of trees your answer will always give you better answers. No, purely based on a data set. If you have more than 4000 records, then you can definitely go for a higher number of trees value. But since the data set is only 400, so I don't suggest anybody to go beyond 30 or 40. Okay, so I hope you understood this random forest classification and its application in the machine learning. So thank you for watching this video. Happy learning.